Hey, what's up, everybody? I'm Divya. Welcome to Visual Vibes. In this Python course, I'm gonna teach you everything that you need to learn to start coding with Python. This course doesn't cost you anything, it's totally free for you. But if you would like to help me out, then you can increase its reach by hitting a like button, leave a random comment down below, share, and subscribe to my channel for more videos. Thanks in advance, and I really appreciate it. Without getting any delay, let's jump right in. In our last session, we have seen arguments in functions, right? So in today's session, let me talk about scope of variables and generator functions in Python. So before I start, I would like to mention you one thing. If this is your first visit to my channel or if you are new to Python course, then I highly recommend you checking out my earlier sessions of this video first and then circle back here for a clear understanding because those videos help you building a strong foundation in basic concepts before you jump into the newer concepts, as well as those will help you in following some sequence. Now let's jump on to the first topic, scope of variables. Scope of variables in functions is simply the one that determines or helps in knowing about where the variable can be accessed as well as modified in a Python script. Let's say suppose in our Python script or program, we have declared one variable. So in order to access that variable, we need to know, right, where the variable can be accessed. So in order to access the variable, where we need to declare. So all these things we need to know. So that is simply nothing but the scope of variable within that Python script or in functions. So before we see this scope, let's talk about the types of scopes in functions. So we have four types of scopes: global scope, local scope, enclosed scope, and non-local scope. So let's see each one of the scope and its examples in detail. So first one is about global scope in functions. So generally global refers to the entire part, right? So global scope in Python simply refers to the variables which are defined at the top level of a script or a program or a module, which can be accessed throughout the entire program, including functions, but with declared explicitly as global keyword. That means whatever the variables that we defined at the starting of our program, then those variables can be called as a global variables. So those variables we can access anywhere in the program. So in order to access those variables in functions, we need to declare first those variables with the help of global keyword, and then we can be able to access as well as modify those variables. So I have given some examples demonstrating the global scope of variables in functions. So first one is about accessing global variable. So here if you can see at the starting I have declared one variable. So I can say this, since I had declared this variable at the starting of the program, I can say this variable is a global variable. So, and in third line, I had a declared one function named my function. In this function, I was trying to access this variable, which is a global variable. So I'm printing one message saying that value of a is a. So this value, with whichever I declare the value of a at the starting, I was trying to access inside this function. And in the sixth line, I was calling this function with the function name. So whenever I call this function will be invoked, and inside this print statement will be there, and then this will be printed in the output along with the value of a. So here you can see value of a is 2. So here, like this, we can able to access the global variable inside a function. Even though if we have some other function below this also, so whatever or how many functions we have in our Python script, we can be able to access the global variables anywhere in those functions. And second example is modifying a global variable. So in order to modify a global variable, what we need to do means so inside this, what we need to do means, like, first of all, we need to declare that variable inside that function with a global keyword, and then we can be able to modify that variable. So here you can say I have declared initially the global variable as a 2, and inside I have defined one function inside that function. So I want to modify the global variable value. So before I modify, so I have declared again the value of a with the global keyword, and then I was tried to modify the value of 2 by adding the value of 2 to the variable a. And then I was printed given some print message, the value of a is a. So here I have declared the function like this, and then lastly I have called this function. So that should give me the output as like this, value of a is 4. So before you modify a global variable inside a particular function, the first thing you need to do is to declare the variable with a global keyword, and then you can do whatever modification you need to do. You can be able to do then only. Now let's see the third example. Global scope in modules allows you to declare or define the variables at the top level of a script or a module, which can be imported as well as used in other modules. Suppose if you have two modules or files wherein you have declared the variable globally in one file and you want to access the global variable in another module or file. So in those cases, what you need to do means, first of all, you need to import the module 1 in module 2, and then you can be able to access as well as modify in module 2. Let's see here one example I have given, wherein I have created two files or modules named module1.py and module2.py. For simplification and to show you the example, I have given the entire two files code in one file only. But normally I have created two files separately. So first file name is module1.py and the second file name is module2.py. So in first file, I have declared one variable globally, assigning a value to it. So I want to access this global variable in another module or in another file. So what I did, first of all, I imported this file1 or module1 with the help of using import keyword. So you need to follow this syntax, import space file name. And then I want to modify the value of API key or the variable which is declared globally in file1. So here I have assigned another value to it, and then I have printed the value of API key. So that should give me the value of this one, because here in module 2 I have already accessed this API key by the importing the entire module 1 or file 1, and then I have tried to modify the value. So whenever I try to print that should give me this value. So here like this, if you want to access the variables that are declared globally in one module in another module, you can follow this format. So this is about global scope of variables in modules. Now let's talk about the second type of scope, which is the local scope. So from the name itself, we can simply understand local scope means the variables which are defined or declared inside a particular function or functions and only accessible within those functions only. Global scope Global scope refers to the array of variables that are accessible to the entire program, whereas local scope variables are the variables that we can access only inside the functions. So here I have given one example wherein I have created one function named my function, and inside this I have defined one variable assigning hello user value to it, and then I had printed the message. So outside this message I tried to call this function. So whenever I try calling this function, so this function gets executed, and then hello user value will be allocated to this message variable, and then lastly it will print the message. So whenever I call this function, these statements will be executed, and then I can be able to see the message or output like this, hello user. Let's say suppose instead of calling this function, if I was trying to access the value of variable which is declared locally inside this function, means like this print of message, then it should give me the error saying that name message is not defined, because this message variable is declared locally inside this function only. So whenever I was trying to access outside the function, then it is giving me this message, name message is not defined. So like this, if you want to restrict the value of variables that we need to access inside a particular functions, then we can be able to use the we can be able to we can very well declare those kind of variables with locally inside the particular functions. Like in real world scenario, in real world I can give you some examples. Like let's say suppose we have a library setup system. In our library, like we have so many kinds of books out there, right? So let's say suppose if you want to give access to the particular kind of books to a particular kind of people, then we can declare the list of those books inside that are available inside a particular function. So like this, we can be able to restrict some of the values within those functions with the help of using a local scope. concept. And the third type of scope is an enclosure scope. So enclosure scope allows you to declare the scope of a variable that is defined in outer function, which can be accessed by the inner or nested function. So I can say simply, if you want to access any variables that are declared in outer function inside inner functions, then you can go for enclosure scope. So those are the variables which are declared in an outer function that are not related to global as well as local. But simply I can say the variables that are declared in outer function are enclosed in that outer function. So those variables, if inner function wants to access means, then that comes under enclosure scope. So here I have given the example for enclosure scope, wherein I have declared a main function and or an outer function. So within this function, I have assigned declared one variable and assigned value to it, saying that hello from outer function. So inside this function itself, I have declared another function which I can call as nested function, named inner. And inside this function, I was trying to print the value of message variable. So here you can see this message variable I declared in the above the nested function. Means this variable is belong to the outer function or the main function. So this variable that comes under enclosure scope variable. So inside this function I have declared, so I was trying to access inside this nested function. So this is simply nothing but accessing the enclosure variable from the outer function. So after I declare this inner function, I was called this inner function, and I'm done with the outer function statements. And then finally I call this outer function. So whenever I call this outer function gets started executed. Start its execution. Then inside this function, it was try to allocate this value to this message variable that is in an enclosure scope, and it invokes this function or nested function. In this nested function, inside this we have a print statement. So it was trying to, what it will do means it will try to access the message value from this outer function, and then it will try to print out that value. So finally, so here I have declared only the function definition. So in order to call this function, so we need to give the inner function call, right? So that's why I have given the call in this inner function call. So whenever a Python compiler sees this inner function call, so this function will be will be executed, and then inside this print we have a print statement. So finally it will print the message of hello from outer function. So here you can see in the output we have a message call which is hello from outer function. So in this outer function, I have declared this variable, but inner function also can be able to access. So this scope we can call as enclosure scope. Now let's see the fourth type of scope, a non-local scope. So it is similar to the enclosure scope, means we can be able to access the variable that is defined in an outer function in an inner function, but along with accessing the variable inside inner function, we can do one more thing, that is modification. If you want to modify the variable that is declared in an outer function if you want to modify a variable inside inner function by accessing the value of variable in outer function, then we can access with the help of non-local keyword inside the nested function. So here I have given the example for non-local example. Same example you can see, but a slight difference. So here I have the function named outer function, wherein I have declared one variable named message, and I have assigned value to it. And I have declared an inner function as well inside this outer function. And then I have redeclared the value of redeclared or defined the variable with the non-local keyword. And then after redeclaration, I was trying to modify the value of message variable. So initially we have the value hello from outer function. So inside this nested function, I was trying to modify it like this, modified hello from outer function. And then inside the inner function, I printed the given the statement for print. And then finally, I call this function inner function. So this is from third line to sixth line is function definition for the inner function or nested function. Suppose if we want to call this function, then we need to call this function, right? So we have a calling statement for inner function in the seventh line. So finally, I call the outer function. So whenever I call this outer function, so it starts executing the outer function, and inside this function, some value will be assigned to the message variable. and it starts executing this inner function. So inside this, Python compiler will check that this message variable will be is declared with the non-local keyword and then assignment of new value to it. And then finally, it will print this message. So after this execution of these statements, it will see this function call. So whenever it sees this function call, this function will be executed. So here if you can see the output of this non-local example, so it's printed the message modified hello user from outer function. So finally it printed the value that is modified inside the nested function. So this is all about the scope of variables globally, locally, enclosed, and non-locally. Now let's see generator functions in Python. So in our previous sessions, we have seen functions with a return keyword, right? So in normal functions, what return keyword will do, like we will use the return keyword inside the functions to return some values that are declared or defined or inside that particular function. Whereas generator functions are the ones, or also the functions related to normal functions only, but in generator functions, we will use the yield keyword instead of return keyword. So these generator functions returns the values on one at a time. Like instead of returning a single value or the entire value at once, these generator functions returns the values one by one at a time. And these generator functions uses the yield keyword inside the functions. And each time whenever yield keyword is called or Python compiler will see this yield is called, what it will do means it passes the function and then the value is returned. Whichever the value that is present at that time, that value is returned by pausing the function. So once the value is returned or when a loop asks for the next value, the function resumes whenever or where it is left. Let's suppose for the very first time, whenever a Python compiler sees the yield keyword, like it returns the value. Once the value is returned, for the next value in the loop gets started iterating means then function at that point of time, function again started resuming and from where it left off, and then it continues returning the second value, third value, like that. It will keep on going. So here, if you can see the example, I have a declare one function named count up to. So wherein I was passing one parameter to it, maximum named as maximum parameter. So inside this function, I declared one variable named count and assign value to it. So inside this function, I want to check whether this count value is less than the maximum value. So if this count value is less than the maximum value, I want to return the value. So I have declared like that, like yield space count. Yeah, this means at this point of time, whenever this statement gets executed, it will return this yield keyword will return the value. So initially we have the value as a value of count as 1. So at this point of time, it will return the value as 1. So like this, so inside this condition, I have given yield count, and then after that, I started incrementation by incrementing the value of 1 to the already declared count variable. So inside this function, I have declared the statements like this. And then I have declared one more for loop as well, wherein I want to loop through this function using this iterator called by passing the value of 4 to this function. And inside this loop, I want to print each and every value. Whichever I was iterating the value inside this function, I want to print each and every value. So whenever I execute this file, what it will do mean it comes first of all. This is the function definition. So whenever this function definitions whenever this function will be called at that time only, this function will get executed, right? So first of all, it will come here, it will check the function definition. So yeah, it comes to the 7th line and then it checks this for loop. And here in this first statement, I have called this function count underscore up to by passing this value. So it will call to the function call will happen here and then by passing the value as 4. And count is equals to 1, it will assign while it will check this condition 1 less than 4. So it condition becomes true, and inside this Python compiler will see this yield keyword with the count. This means it returns the value. So whenever it returns the value, we have the count value as 1, so it returns the value to this for loop. So whenever the value is returned, so this for loop, inside this for loop, we have a print statement num. So it will initially print the value as 1. And again, So here, whenever Python compiler will see this yield keyword, right? So it will passes this function. First of all, it will passes this function and the value is returned to this for loop. So once this for loop gets executed, means it prints the value of num means when the Python is ready for this for loop is ready for next iteration, right? So again, in the next iteration, this for loop is called again. This function is called again. Like that, it will happen normally, right? But what it will happen means, like whenever it sees this yield keyword, it pauses the function and returns the value. So the value gets returned to this for loop, and then it prints the value of that return value. Once it prints the value, then again Python compiler resumes the function from this from where it is left off. It resumes the function. So previously it is left off here, right? So when again it started executing this statement, the next statement. So here we have the incrementation part. So the count value will get incremented to 1. Previously we have 1, now it get incremented to 2. So again, it will check this condition while count less than maximum. So 2 less than 4. And again, inside this condition, it will it will see this yield keyword. Again, this value gets returned to this for loop. It prints the value of num as a num. So this time we have the value as 2. So like this, the process continues for the last value also. And then finally, it will print the value of 3. So this condition will go for, so maximum value we have given as a 4. This condition goes up to 3 less than 4 only, right? 4 less than 4 will not satisfy. So 3 less than 4 up to 3. This condition will be satisfied. So in output, we can see the iterator object. So this we can call as iterator object or the values. The output as a 1, 2, 3. So like this, you can see, right? Whenever loop asks for the next value, the function resumes where it left off. So like this, function pauses whenever yield keyword is called and resumes for the next value from where it is left off. So this is about generator functions. Now let's see the the difference between the return and yield keywords in functions. So I have given four differences. Let's see each and every one. So the first difference is about like in whenever we use the return keyword, it returns a single value, like whatever the result we have up to now inside that function. If you return that entire result means it will be returned as a single value only. Whereas whenever we use the yield keyword in functions, it returns the entire generator object or iterator, I can say. Means yield returns one value at a time, whereas return returns the entire single value or the entire result once. Return ends the function, like when the functions with return keyword ends the function execution after value return. So once the value is returned, the function gets ended there itself. But in yield, when it comes to yield in functions, first of all, what it will do, whenever Python compiler sees the yield keyword, it first passes the function and the value is returned. So for the next value in the iterator, it resumes the function and then it's keep on going like that. And return keyword loads all the data or the entire result at once only. Like whenever you use the return keyword, it returns all the entire result at once only. But wherever functions with yield only loads one item at a time. And return keyword, like whenever you use the return keyword in functions, like whenever we have the use of only simple value, returning a simple value, then we can go with return keyword in functions. Or let's say suppose if you want to return the large data sets or we need to stream a large set of data means then we can go for yield, using of yield in functions. So these are the simple differences of using return and yield keywords in functions. So this is all about scope of variables in functions and generated functions in Python. So that's all for today. I hope you like this session. If you have any doubts, feel free to post them in the comment section. We'll definitely answer your questions and I will see you in the next video. Until then, take care, goodbye, and enjoy programming.